guys, welcome to Sir J's Math Lessons. In today's video, we will be dealing with the concept of continuity and discontinuity of a function. Actually, the idea of continuity is very important in the study of calculus. You know guys, we can say that the function is continuous at a certain point if we can trace the graph of the function without lifting our pen. So geometrically, for example, just imagine na meron kang draw na graph, okay? You can think of it that the function is continuous at every number in an interval as a function, this graph has no break in it. Parang kayo lang ang jowa mo. Walang break. So that's continuous. Hindi pala. Minsan meron pala nga na. Minsan pala, nagbe-break. So doon pumapasok yung discontinuity. So joke lang yan. Kidding aside. So you can sketch the graph of a function without removing your pen from the paper. So that's continuity. So pag nalabag yun iyon, yung tinatawag nating discontinuity. So let's consider a certain example. So let's say we have this kind of function. For example, we have the function, let's say we have f of x is equal to x squared minus x plus 1. This function is actually continuous in the entire real number. Actually, this is a quadratic function in which the domain is elements of real number from negative infinity to positive infinity. Now, for example, another example is, anyway, you can sketch the graph of this. You know this already. The graph of quadratic function is a parabola. Okay, and this is continuous in the entire real number. Now, for example, another one is, let's say you have g of x is equal to a piecewise function. First rule is x squared, where x is less than 2, and we have 1 where x is greater than 2. So this piecewise function is actually continuous. The first rule is continuous in the interval negative infinity, negative 2. Negative 2 to negative infinity rather. The second rule is continuous in the interval 2 to positive infinity. However, if you're going to evaluate the limit of g of x as x approaches 2, okay, the limit of this function does not exist. And because of this, we have to follow different conditions in order for us to determine if a certain function is continuous or not. Okay? So, by definition, I think gonna erase this first. So, palitan muna natin. Erase ko muna ito lahat. Yan, tanggalin muna natin yan. So By definition, a function is said to be continuous at a point if and only if the limit of f of x as x approaches a is equal to f of a. Okay? Now this definition implies that we have to follow three conditions, and these three conditions must be satisfied for the function to be continuous at a certain number. And these are the following conditions. First, the f of a must exist when you evaluate the function, when you directly substitute the a, so it must exist. Second, the limit of f of x exists as x approaches a. So in this case, you have to test the left-hand limit and the right-hand limit of a function. And third condition, the limit of f of x as x approaches a should be equal to f of a. So these are the three conditions in order for us to determine if the function is continuous at a. Now bear in mind that if at least one of these three conditions fail, we can say that the function f has a discontinuity at a, or f is discontinuous at a. Now for the discontinuity of a function, actually we have different types of discontinuity. So the first one is if the function is discontinuous at a, and it so happens that the second condition is not satisfied, or is not, if the second condition is not satisfied, the limit of f of x as x approaches a exists, then the discontinuity is called essential. The discontinuity is called essential or non-removable. Okay, essential or non-removable. Now essential, this kind of discontinuity can be classified as infinite or jump. Okay, so essential or removable discontinuity can be classified as infinite or jump discontinuity. So for example, the graph, if you have this kind of graph, let's say we have the graph of a rational function. Say this is -2, say this is the asymptote. Okay, then you have this graph, the other one is here, and meron din dito. Okay, so let's say the graph, the function f of x as x approaches -2. So in this case, whether you test the limit, the left-hand limit and the right-hand limit, they will not be equal. Therefore, the limit of f of x does not exist. So case number 2 or condition number 2 is not satisfied. So we can say that this is non-removable infinite discontinuity. Okay, now if you have this kind of graph, also for example we have a parabola, Yan. Anyway, pag nakakita kayo ng ganitong condition ng function, we know already that parabola is continuous. So now, pag meron tayong circle dito, ibig sabihin may certain condition yan. Okay, so it might be less than some number. Okay, so the other graph is, let's say you have shaded circle here, then papunta doon. Let's say linear function yan. Ayan, so kung makikita natin dito, ayan, so let's say our number is, say we have positive 2 in this case. Let's say we have positive 2. Ayan. So this kind of graph is said to be ayan, this is jump discontinuity. So as you notice, jump discontinuity occurs whenever the graph of the function terminates at one point. So na-stop dito, terminates at one point, and jumps at another point. So halimbawa, simula dito, from extreme right, papunta dito sa baba. So na-stop na dito. Then, ang nangyari, nag-jump doon. Okay? So, you will notice that if you're going to evaluate the left-hand limit and the right-hand limit of this function, we can say that the limit will exist. So let's say find the limit of f of x as x approaches to from left. So from left, papunta dun yung graph natin. Okay? So it will exist. So this is a certain number meron dyan. So let's say this is 3. So the limit is 3. So dito naman, the limit of a function as x approaches 2 from right. So from right naman, papunta dito, meron din siyang napupunta ng certain number. So they both exist, but the limit exists but unequal. So take note that for the jump discontinuity, the limit of the function f of x as x approaches a from left or from right, from left, dito ka nalalagay left or from right, both exist. Okay, both exist, but they are unequal. So we call that as jump discontinuity. Okay. Now let's proceed to a good example of continuity of a function. Determine whether each of the functions below is continuous or not at a given value of a. So we have the first function f of x is equal to 1 over square root of x squared plus 4, where a is equal to -2. So this will be our solution for number 1. Now, how do we write the limit of this function? So we can transform this as the limit of f of x. So our f of x is 1 over square root of x squared plus 4 as x approaches -2. Now, let's apply these three conditions. First is find f of a. So f of a, so it should be f of, should be f of it should be f of negative 2. Should be f of negative 2. Ano ba yan? Yan. So f of negative 2, so this will become 1 over square root of, that's just plug in, x is negative 2. So this is negative 2 squared plus 4. So just simplify. Negative 2 squared is positive 4, right? So this is positive 4 plus 4 is square root of 8. So we have 1 over the square root of 8. Ano ba to? So we have 1 over square root of 8, or we can simplify this as this is 1 over 2 times 4 is 8, so we have 4. Square root of 4 times 2 is 2 square root of 2, so we have 2 square root of 2. Then rationalize, multiply by square root of 2 over square root of 2. So we have the square root of 2 over 4, because square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2 times 2 is 4. So f of negative 2 is square root of 2 over 4. So in this case, f of a exists. Next, how about the second condition? For the second condition, we have limit of f of x, the 1 over square root of x squared plus 4, as x approaches negative 2 is equal to, no, since the negative 2 is defined in our radical, kasi kahit anong number na pag in-square mo, actually kahit negative yan, pag in-square mo dito, laging positive pa rin. So, laging ma-define natin. So, in this case, the limit of the function f of x as x approaches negative 2 is still square root of 2 over 4. So, etong dalawang, ito, tsaka ito, the f of a exists, the limit of f of x as x approaches a exists, and definitely the third condition will be satisfied. Okay? So we can say that this function is continuous at a is equal to negative 2. Now you can try to sketch the graph. You can sketch the graph of this function. So you can use actually your graphing software, or I suggest you can use GeoGebra. But mag-manual muna tayong graph. So paano ba yung gina-graph? So in this case, ito ay medyo pasimplin lang muna natin. By inspection na lang tayo, ha? So since define naman to sa lahat ng number, we can try 0 muna, 0. So if x is 0, y is 1 over square root of 4. Square root of 4 is 2, so 1/2. So 1/2 is 0.5. Yeah. So this is 0.5. Yan. If x is 0, y is 0.5. Now try tayo ng number na 1, then negative 1, kahit tig-isang number lang. Now if x is 1, this will become, function will become 1 squared plus 4. So that's 1 squared plus 4 is 5. So we have 1 over square root of 5. And 1 over square root of 5 is actually that's 0.44. Yan. So 0.44. So nandito lang yan. Kung 0.44, 0.5 ito. So mababa lang ng konti. Ayan. Ayan. Okay. So dito lang siya. Now if we're going to use the -1, actually we will get the same answer since yan naman ay naki-square. So ganito lang din yan. So the graph will look like this. Ayan. Ito rin. Ayan. This is actually asymptotic to the x-axis. Bakit? Kasi kahit anong number gamitin ko, kahit lumaki ng lumaki yung number dito sa negative infinity, ito rin, sa positive infinity, dumiretso doon, it will never be 0. Kasi laging may 1 dun sa taas. 1 over something. Okay, so palit ng papaliit. As x gets bigger and bigger, left and right, ng number line natin, mas lalong lumiliit ang f of x natin. So papunta doon. Now, if we look for a is equal to -2, so somewhere there yan, nandito, -2. Ayan, so makikita natin na meron siyang na-approach na certain number. Ayan. So obviously, the limit of this function as x approaches -2 from left and from right exists. Okay? So yan yung graph niya. So therefore, this function is continuous at a is equal to -2. Now, let's answer number 2. Sorry. For problem number 2, we have the g of x is equal to x plus 1 over x squared minus x minus 2, where a is equal to 2. So first condition, para hindi maging redundant yung number, gawin na lang natin, let's say a, first condition, or hindi, ito na lang pala. Yan. For first condition, we will try f of a. So f, in this case, we have f of 2. This is g of 2. So g of 2 is equal to 2 plus 1 over 2 squared minus 2 minus 2. Now, let's simplify. 2 plus 1 is 3 over 2 squared is 4 minus 2 is 2 minus 2 is 0. So therefore 3 over 0. Now, what does it mean? 3 over 0 actually is undefined. Undefined. 3 over 0 is undefined. Now, first condition is not satisfied. So, sabi natin dun kanina, at least any one of them is not satisfied. Then we can say that the function is discontinuous. Okay? Now, what kind of discontinuity? Kung discontinuous siya, ngayon, what kind of discontinuity? Now, you can manipulate this. Let's say, if a factor natin siya, g of x is equal to x plus 1 over the x squared minus x minus 2 can be expressed as factored form na x minus 2 times x plus 1. Okay? Now, when you sketch the graph of this function, actually, parang matitira na lang sa'yo ay ito, 1 over x minus 2. Ayan. So, you can cancel x plus 1. Now, when you sketch the graph of this function, since rational function na yan, so, parang ganito na magiging itsura niyan. So, we have 2 here, and that would be the vertical asymptote. And the horizontal asymptote would be 0. Yan, 0 doon. Yan, kasi mas mababa yung degree nito. Ngayon, anong giging graph? Sorry. Anong giging graph? If x is 2, so bawal. Now, try if x is 0, we will get negative 1/2. So, test lang na tayo ng konting number sa left. So, if x, let's say this is negative 1. We try, let's say, 1, ano? If x is 1, y is negative 0.5. So, located dyan dito. Ayan. So, ibig sabihin, ang graph niya ay dito yan. Pag ganun. Ayan, ganyan naman kasimple para mag-graph ng rational function. Now, if x is to the right naman, let's say, gamit na lang tayo ng 3. So, if x is 3, this will become 1 over 3 minus 1. 1 over 3 minus 2 is 1. So, 1 over 1 is 1. So, nandito yan. Okay? So, ito naman yung magiging graph niya. Yan. Ayan. So, kung mapapansin natin, kung kukunin natin yung left and right hand limit, parehas sila ditong approaching infinity. Okay? So, lesson ng infinite limit. So, makikita nyo dito as x approaches 2 from right. Ayan. So, the limit of the function approaches infinity. Positive infinity. As x approaches 2 from left, so pababa naman dun. So, negative infinity. So, limit does not exist. Okay? So, what kind of discontinuity is this? So, this is actually non-removable infinite discontinuity. Okay? So, I hope ay nakuha kayo. So, that's actually simple example muna ng limit ng continuity and discontinuity of a function. So, next video, we'll try to I'll try to give you some applications of continuity and discontinuity of a function. So, for now, yun muna. Let us have a review. Muna, so ito yung tatandaan natin. A function is continuous at a point if and only if the limit of f of x as x approaches a is equal to f of a. Then, these are the three conditions to be satisfied. The f of a must exist. The limit of f of x as x approaches a must exist also. And they are equal. Okay, f of a and limit of f of x as x approaches a must be the same. Now, in case na meron siyang discontinuity, so we have two types. Again, if at least one of these three conditions fail, so we can say that the function f has a discontinuity at a. So, in case na discontinuous siya, so we have two types of discontinuity. The first is essential or non-removable. Okay, yan yan. And for essential discontinuity, it can be classified as infinite or jump. So, pag infinite, ito yung usually pag may pag infinite ang makukuha mong limit niya sa left and right hand limit. Kapag jump discontinuity naman, so ito, natitigil sa isang point, then nagja-jump. Ang limit niya nag-e-exist, ang left and right hand limit niya nag-e-exist, but they are unequal. So, that's essential. Now, when we say removable discontinuity, so actually, pag sinabi natin another one is removable, pag sinabi natin removable discontinuity, removable. So, when we say removable discontinuity, ito yung pwede mong i-manipulate. You can factor the function, then you can rationalize hanggang sa mawala na yung discontinuity ng function na yun. So, one good example is, let's say you have y is equal to x plus 2 over x plus 2 times x minus, let's say x plus 2 squared over say ito lang. So ito pag sinimplify natin ito, makukuha natin ay x plus 2 na lang. And actually linear function yan. Now kung i-graph natin yan, ang mangyayari doon sa part ng negative 2, hollow dapat ang circle. So ang tawag natin doon ay removable discontinuity. Okay? So thank you guys. Sana nakatulong. If you have any questions, comment lang kayo sa baba ng video, or you can just message me to my clarifications. So thank you guys.
Paalam!